In today's lesson 4, we're going to talk about the sine function. The sine function matches the measure of an angle in standard position with the y-coordinate of a point on the unit circle. This point is where the terminal side of the angle intersects the unit circle. So we're going to look at the properties of the sine function. The first number a in our standard form equation, a times sine b theta. Our first number a, that's the amplitude, or the half the distance between the maximum and the minimum. So the amplitude here is 1. The b value is the number of cycles in the interval from 0 to 2 pi. And if we want to find the period of a sine curve, we do 2 pi divided by b in the formula or equation that we're given. So in our picture here, this is the amplitude from the definition of amplitude, half the distance between the maximum and the minimum. And from 0 to 2 pi, this is the period of the curve. Now, we want to notice that there are 5 key points in one cycle of a sine curve. The first key point is at the origin. That's an intercept. And then there's a maximum point, another intercept, a minimum point, and then another intercept. So if you think about the sine curve, if you know the starting spot and the ending spot, halfway in the middle is another intercept. And then in the first half, there's a maximum. In the second half, there's a minimum. So to identify these 5 key points in the sine curve, the first one is an intercept. That's at the origin. And then there's a maximum point. That's at pi over 2, 1. And then there's another intercept. That's at pi 0. Then there's the minimum point at 3 pi over 2 and negative 1. And then lastly, there's the intercept at 2 pi 0. So those will be really helpful if you know that pattern. Now, making a table of values, I've done this with my calculator. The sine of 0 is 0. The sine of 30 degrees is a half. The sine of 60 degrees is 0.866. The sine of 90 is 1. The sine of 180 is 0. We've got negative 0.71 at 225, negative 1 at 270, negative 1/2 at 330, and back to 0 at 360. So in our next page, we're going to plot those points on our grid. So if we plot the intercept at 0, 0, at the end 360, and at 180, then we know at 90 we have a high point at 1, and at 270 we have a low point at negative 1. And connecting those dots together, the full cycle, one full cycle, we would hit those other points from the table. If you looked back at your table, at 60 degrees, we're about 0.87. Whoop, I didn't mean to erase that. At 60 degrees, we're about 0.87. At 225, we're about negative 0.7. At 330, we're at negative 1/2. So you can see it matches along those values. For example 2, we're going to use the graph of the sine function to find the amplitude, and that's really simple. The amplitude is 1. You can tell between the midline, if this is my midline here, half the distance between the maximum and the minimum is 1, so our amplitude is 1. We want to find the period of the function, and the period, since it's a sine curve, the 5 key points: intercept, maximum, intercept, minimum, intercept. So the period is 2 pi, or 360 degrees. And the domain of the function, well, the domain would go on forever. Since it's periodic, it just keeps repeating. But the range goes from 1 to -1. And that's on our y values. So I'm going to write the range using y values. Then if I want to estimate the sine of 2, well, I know that pi over 2 is 1.5, 1.57. So 2 is going to be in here somewhere. And if you come up here and look, it's really close to 1, but not quite. So I'm thinking that 2 is right about there, since pi is 3.14. So I'm thinking 2 is about, I don't know, 9/10 or 0.85. So my estimate is about 0.9. And if I use the calculator, the sine of 2 using my calculator is actually about 0.909 or 0.91. So we're actually pretty close to an estimate using the graph. For example 3, we want to be able to use the graph to find the period of the function. And because our lesson is only about sine curves, we know the 5 key points are supposed to be intercept, max, intercept, min, intercept. And once we complete those 5 key points, you can tell that the period completed in pi units. So the cycle is complete between 0 and pi. That's the period. So our period is pi, or 180 degrees. In this next one, it looks like intercept, max, intercept, min, intercept stops right there. So we got one cycle right to here. And then it repeats again if we switch colors: intercept, max, intercept, min, intercept. We have a second cycle right here. And then repeating again: intercept, max, intercept, min, intercept. You can see we have 3 cycles completed in 2 pi. So that tells us if we have 3 complete cycles in 2 pi radians, then we're getting 2/3 for the period, for one period, 2/3 of a pi. Example 4, we're talking about finding the amplitude for the graphs. In the first one, the amplitude looks to be 3. So from our midline to the maximum and the midline to the minimum. So the amplitude is 3. And in this one, amplitude looks to be 4 units. So 3 and 4 there. In example 5, we're going to sketch one cycle of a sine curve that has an amplitude of 2 and a period of, let's see, that didn't get, of 3 pi, I guess that's supposed to be there. So we want to write the equation for that graph. So first let's give it a sketch to draw it. So if we have an amplitude of 2 and a period of 3 pi, we're going to start at 0, 0 and stop at 3 pi. So at 1.5 pi, there would be another intercept, because I'm thinking about those 5 key points. And then halfway between this first point and the second intercept, halfway between would be right about there. And the amplitude is 2, so we're up here at 2. And then in the second half between 1.5 pi and 3 pi, so right in here, we have a minimum point. So we got an intercept, maximum, intercept, minimum, and an intercept. I'm going to come up here and put in 3 pi was missed in typing. Okay, so the amplitude is 2, the period is 3 pi, And the key points, they've reminded us the intercept was 0, 0. The maximum would be at 3/4 of a pi and 2. Another intercept would be at 3 pi over 2, 0. The minimum would be at 9/4 of a pi, because 2 pi is 8/4 and 2.5 is 9/4. So that minimum is -2. And then the last intercept is 3 pi, 0. So if it's easier, you can label them right here on the graph to make them show up a little more clearly. And this one's 3/4 of a pi and 2, and we have one intercept at the origin and 1.5 pi, 0. So our 5 key points. Now we're going to write the equation. So the b value is going to be 2 pi over 3 pi. So to find the period, we do 2 pi over b, and our b is going to be 3 pi. So 2 pi over 3 pi makes our b value 2/3. The equation would be a times the sine of bx. So 2 sine 2/3 x. Now you can get your calculator and check on that graph with your calculator to make sure it looks like our picture here. And when you're satisfied, you can move on. And finally, our last example, we want to sketch one period of y equals -3 sine 1/2 theta. So here's the trick. When the amplitude is given, you always answer with a non-negative number. So our amplitude is 3. And then to find the period, as in the previous example, we want to think about 2 pi divided by our b, and this is our b value here. So 2 pi divided by 1/2 means the period is going to be 4 pi. So we'll see that this graph is stretched out pretty far. And we know what the key points are, and they're telling us the key points again here. So if we start at 0 and we stop at 4 pi, then halfway between is 2 pi. So we got the intercept, intercept, intercept. Now notice that the second point is minimum, and the reason that the second point is minimum is because we have an amplitude, or we have a negative a value. So the a value is negative, switches the order of the min and the max, but keeps the intercepts. So instead of having an intercept maximum, intercept minimum, we're going to have an intercept minimum down here and an intercept maximum up here, and then finally the intercept. So our graph goes down first before it goes up and then stops. And labeling our key points would be the origin, pi -3, 2 pi 0, 3 pi 3, and the last intercept 4 pi 0. And that's the end of our sine curve lesson. See you next time.